You well, folks? Well, it is an absolute pleasure. Jesse, thank you very much for the kind invitation. And David, thank you for co-hosting and co-chairing this session, and for the, as good as it gets, setting of the stage of what I'm sure it will be a very interesting technical market session today of all presentations. It is a pleasure to speak with you today, and happy to connect with anyone after the presentation. A couple of words about Neo Performance Materials. We are primarily in the midstream and downstream of rare earth supply chains. We're the only company with end-to-end supply chains, both inside of China and outside of China. We own and operate the only separation facility in the Western world in Estonia, and we are the first ones that are now building the first sintered permanent magnet facility at scale, spec'd for electric vehicle drivetrain motors. Also, we're doing that in Estonia, right next to our operating currently separation facility is. As of about 9 months ago, we also went back into the upstream, which I'm sure as the presentation evolves, you'll understand the principles behind doing so. Specifically, our project in Greenland that Jesse mentioned earlier, and where I'm going to next after Montreal. Rare earths. The reason I insist on speaking, what are rare earths, although I'm sure in this room everybody knows what rare earths are and why they matter. About 2.5 years ago, when I actually got into the rare earth industry from the dark side of banking and consulting, I noticed a member of the European Parliament asks a question to the EU Commission, and this is what they do. They do written questions, and then they get responses by law. They have to get that response by the Commission, and they said, well, what are you doing for the EU's rare earth supply chains, and specifically how to fit them in the EU Innovation Fund? And the response was, we're doing great things for the batteries. So let me explain why rare earths help with battery economics and the mass balance of battery materials in electric vehicle, but have not so much to do with batteries. So right now, rare earth mixed oxides, specialty rare earth mixed oxides that are used by BASF or Umicore, they're used as emissions catalysts. They're also used as water purification products that help municipal and industrial water treatment plants efficiently remove phosphorus. And they actually, fight dangerous algae blooms in freshwater resources. My favorite example is their use of, when you make bonded magnets out of rare earths, their use in water circulation pumps, like the ones that Grundfos makes, for example, and they're our customer. They're actually one of the first companies that, before it was cool 15, 20 years ago, they demanded supply chain optionality. So both inside of China produced rare earth bonded magnets, and outside of China, end-to-end rare earth bonded magnets. And the reason they're my favorite application is that their devices, these water circulation pumps in residential, commercial buildings, probably in this one too, that when you use these magnets in the last few years, Grundfos in the EU, where they did a life cycle assessment and a study, when you use these rare earth permanent magnets, you actually save the equivalent in the EU alone of the installation of 2 average nuclear power plants. That is how much energy was saved. Then about 70 or probably more % of offshore wind turbines use rare earth sintered permanent magnets to reduce the maintenance requirements, increase energy efficiency, and make them more grid compatible. But looking forward, looking into the next couple decades, the majority of the growth, the 500 to 600% growth of rare earth demand, depending on which market analyst you follow, is driven primarily by the use of sintered rare earth permanent magnets in the drivetrain motors of electric vehicles. 1 to 2 kilograms of a sintered rare earth permanent magnet in the drivetrain motor of an electric vehicle saves you an order of magnitude more of lithium, nickel, cobalt used in the battery. You save about 20 to 30% of the battery size while achieving the same range. So rare earths are magnets. Rare earth magnets are really the linchpin for the transition to green technologies, and they're energy saving. And there are obviously current applications in internal combustion engine vehicles and hybrid EVs, whether it's your power seat or it is your ABS, the anti-lock brake system. There are already applications of bonded rare earth permanent magnets in the automotive industry, and there's only a couple of companies outside of China that are spec'd and are already supplying the automotive industry that way. But let's look, before we look into the future and maybe discuss and debate the future of rare earth supply chains, let's consider a bit of the history, because history might not always repeat itself, but it certainly usually rhymes. Really, the densest scientific advancements of rare earths happened during the World War II's Manhattan Project. There's a reason I say this, and the reason is that the policy interventions required now are probably of that scale, hopefully less polemic, but of that scale and magnitude and bold policy intervention requirement. At the time, the scientists of the famed Manhattan Project were trying to build technologies for the production of actinides, and they needed a safe modeling system. So rare earths are, for those that know the periodic table, I'm sure you all do, the lanthanides and the actinides, they have different different physical properties, but relatively similar chemical properties. And so for safe modeling purposes, they developed a lot separation processes and solvent extraction line technologies to separate lanthanides that then they could use for actinides for other polemic purposes and energy purposes. Later in 1950, the first patents in rare earths took place in the U.S. or came together in the U.S. And in 1952, what was later renamed as Molycorp, the Molybdenum Corporation, acquired the site Mountain Pass in California, which is now owned by MP Materials. And more than half a century ago, or actually 3/4 of a century ago, rare earth mining began in Mountain Pass. A bit later, the Bayan-Obo site, mega site of iron ore mining in northern China began its operations, and from there were byproduct rare earths from the tailings that were produced at relatively low, very low production costs. The first permanent magnet, which was actually a samarium cobalt magnet for aerospace and defense applications, again, was founded and discovered in the 1960s in the United States. But then, in the 1980s, about 1984, the U.S. Nuclear Regulatory Commission and the IAEA tightened transportation standards on low levels of uranium and thorium, classifying them as source materials. This considerably increased the cost of handling, transporting, storing, and disposing these low-level materials. Naturally, one of the outcomes of this policy was that the US and European rare earth separation companies, or rare earth separation assets, shut down. And they actually relocated in China because they couldn't accept any more monazite sands because of their thorium and uranium concentrations. Eventually later, fast forward, Mountain Pass also, the mining site actually shut down in 1999, if I remember the dates correctly. The reason was, again, because of a leak of naturally occurring radioactive waste. It reopened in the late 2000s. In 2011, as rare earth prices were peaking, and there's a reason I stopped the chart there, because then we go into a next phase of the history of rare earths, which is the trailing decade. As rare earth prices were peaking around 2011, 2012, at the time reaching their all-time high, there was a flurry of acquisitions. Molycorp bought the Estonia separation facility, which we now own and operate. They also bought the predecessor of Neo-Performance Materials, Neo Materials, which we made magnets, and we separated rare earths in China, and we also made magnets in Thailand. And so here, before I show the chart of the trailing decade, this is why it's now why rare earth supply chains are considered critical, and the reason for the outcry for supply chain optionality. There are reserves of variable qualities and quantities around the world. There's not a lack of rare earths per se as potential deposits. There's very few of them that are economic to develop, and even less of them that have a timeline that can be permitted fast enough to meet up the challenge. The reality, though, is that 60% of mining right now happens in China, in one jurisdiction, in this case, China. And in separation, it is 90%. 90%, and depending on the year, sometimes it's over 90% of separation of rare earths, and the rare earth value chain happens in China. And then in making metals and alloys, again, it's 90%. And then in permanent magnet production, it's around 90%. In the case of sintered rare earth permanent magnets spec'd for electric vehicles, 98 to 99% are manufactured in China. So the reason I'm saying this is that there is evidently supply chain concentration risk that is in only one jurisdiction. And any OEM that is in a high growth phase, such as in the case of electric vehicles now, or offshore wind turbines, to meet the energy crisis in Europe, and I just came back from Copenhagen, where the wind industry was debating exactly this. How can they have supply chain optionality to manage the risk of being dependent on solely one jurisdiction? Is clearly dependent on, yes, the value chain pricing is dependent on one jurisdiction because the midstream and the downstream is concentrated in one jurisdiction. So it's not just about mining, it's also about the midstream and downstream. And China, the central government of China, has actually quotas about the exports of and production and exports of earth magnets and oxides. And this is the pricing charts of oxides. After the last peak about a decade, maybe 11 years ago, rare earth prices had relatively low volatility. Between COVID, stockpiling for the supply chain crunch that happened in the first couple years of COVID, policy rhetoric, not necessarily tailwinds at the time. Now there's tailwinds, then it was rhetoric. 3 years ago, about the Green Deal in Europe, or the potential of what eventually became the IRA in the United States, rare earth prices increased. China started increasing the quota, though. The government in China started increasing the quota, however, and so rare earth prices fell. Around 2015, 2016, Molycorp, which was the only at the time integrated mine-to-magnet supply chain outside of China, filed for bankruptcy at those prices, because the market was set by one jurisdiction that had its own set of average unit costs. Anything outside of China had a different set of unit costs, but it didn't have customers that were crying out loud for supply chain optionality at the time and would be willing to pay a premium for that different cost structure only for the sake of diversifying supply chain risk. Now, the drivetrain motors, the OEMs that make drivetrain motors for electric vehicles, they have choices, and there's actually a few additions since this chart was made probably a year ago. There are, the rare earth permanent magnet options for drivetrain motors of electric vehicles, and non-rare earth magnet motors for electric vehicles. The dominant technologies are the ones that use sintered permanent magnets, such as the one that Bosch makes, Schaeffler, Brose, Siemens, Nidec, PSA, Dido. Then there's a bonded permanent magnet motor that the Honda Dido partnership makes, which is a very efficient motor and has, I believe, almost zero dependency on heavy rare earths. Then there's induction motors, which Tesla used to use over a decade ago, and then they switched to sintered. And then there's the switch reluctance motors, which Chrysler is using. Since last year, there are public press releases and statements, and this, as far as I can go with commenting on that Ford and General Motors are also going with sintered magnet motors. General Motors has formed a partnership with Vakuumschmelze, the German sintered magnet making company that traditionally serves other industries out of Hanau in Germany. They will be building a sintered magnet plant in North America in partnership with General Motors out of OEM demand. And Ford equivalently is aspiring, I believe, to make 2/3 of their drivetrain motors in North America. In the NAFTA, USMCA region by 2030. And they would be using rare earth-sintered magnets. There's an inherent challenge with substituting rare earth magnets in electric vehicles. There are famed statements of the last investor conference of Tesla saying that they will get rare earths out of their motors, or at least try to. There is also a famed, press release about 2 years ago or 2.5 years ago by BMW saying that they're making motors without rare earths. Our intelligence says that they have teams now working on changing back to sintered magnet motors. And there's an inherent trade-off for this. One is the economic trade-off that you actually save 20-30% of the battery size when you use those 1 to 2 kilograms in the drivetrain motor. You save an order of magnitude more of lithium, nickel, cobalt, graphite. And then there's the engineering trade-off. If electric vehicle automotive OEMs are to minimize costs and substitute magnets in the motors for automotive, for the motor working temperatures and speed, the only alternative technology that would be left would be switch reluctance motors. Switch reluctance motors, however, have low power density, much higher control complexity, and very high noise and vibration. So for the moment, I'm sure there is indeed a lot of R&D out there to substitute rare earths motors, rare earth-based motors, but so far there's no commercial alternative. So the industry has to keep marching ahead to meet the outcry of OEMs. We've spoken about the order of magnitude difference. What makes this time different? Unlike, say, in the mid-2010s, when there wasn't that OEM outcry. The OEMs, as we said, about, in the next decade or two, depending on which market analyst you follow, there's about 500, 600% demand growth expected for rare earths. And I believe it's, again, depending on which market analyst you follow, about 4,000% over the next 2 decades for lithium demand growth. And this time, OEMs realizing the challenge ahead and also the lessons learned from the mid-2000s, they're procuring with one, and they're making the partnerships like the ones that David said, even up to the upstream, even up to the mine. They're investing in mines or doing long-term contracts with mines, MOUs with mines. They are demanding 3 things. One is obviously optionality across the supply chains and ideally localization. European OEMs hope to have most of the value chain produced in Europe. North American OEMs, now we're hearing increasingly more from almost all of them that they want North American value chains, at least as much as possible, certainly the midstream and downstream. When it comes to defense, and we'll speak about the defense sector later. But yes, first they want optionality of their value chain so that they're not dependent solely on one jurisdiction. Secondly, they want price volatility control. Here's why this matters. If an OEM is invested all the way up to the upstream or gives long-term or has long-term pricing agreements with the rare earth value chain participants from mine all the way, from magnet all the way back to the mine, then every time there's a quota change in that one jurisdiction that dominates the supply chain, these mines or midstream facilities, separation facilities or magnet makers outside of China won't become the same story of 2014, 2015. It won't go bankrupt because of that price volatility. There's an inherent lead lag effect across the supply chain when prices go up, and that lead lag, where you get benefit, you get margin expansion, but when prices go down, especially they go down steeply as it's happening now, there's also an inherent cash problem and statistical bankruptcies that happen when the market takes this direction. So to prevent that in the future and have strong and resilient supply chains, you need that long-term price volatility or that price volatility control, which you get either by investing in the earth supply chains, as many automotive companies are doing now, or by engaging in long-term offtake agreements and pricing agreements and volume agreements with the upstream, midstream, downstream. And this is happening as we speak. Every month we hear about a new MOU of whether it's a offshore wind turbine OEM, or it's a drivetrain motor OEM that does an MOU with a mine, or that they even invest in a mine. In a rare case, but it's happening. It's been happening a lot in the lithium supply value chain, and now it's also happening in the rare earth value chain. And third, to meet the increasing regulatory standards on ESG and transparent supply chains, OEMs are also asking for ESG transparency and a contribution of the rare earth value chain to the OEM's product lifecycle assessments. As of a couple months ago, I believe it was the 22nd or 21st of February, the EU finalized the EU due diligence standards, which requires all OEMs now of major industries to report transparently and show continued improvement on ESG criteria. And so in that way, OEMs expect from their suppliers to do the same. I will briefly touch on the public policy tailwinds from three jurisdictions: Canada, the United States, and the EU. Canada, David already touched on many things, but specifically for rare earths, if you look at the last federal budgets and the critical mineral strategy from last December that David summarized, the policies that are catalysts, tailwinds for establishing local Canadian participants in the value chain of rare earths. One is the Canada Growth Fund. Second, it is the Strategic Innovation Fund, where it was actually leveraged. I believe 1.5 billion, give or take. I don't remember if it was 1.3 or 1.8, but 1.5, give or take, to do, give or take, 20% per project CapEx, large-scale CapEx grants support for establishing midstream and downstream in Canada. Then there's obviously support for infrastructure development for mines, and then there's support for R&D and IP generation that is Canadian. The US, unlike for battery mineral supply chains and value chains, the IRA is not that helpful for rare earths. And frankly, the fault is on our industry. We didn't make enough noise soon enough. But we're certainly coming back very strong now and making a lot of noise in all jurisdictions, explaining where earths come into the whole equation. The only support that you get from the IRA as a rare earth or as an aspiring rare earth participant in the US rare earth value chain is through the DoD's, the Department of Defense's Title III program and the Defense Production Act. The not caveat, but just a factor to consider with that is that there has to be a national security dimension in what you do in the United States to qualify for this funding. The reality is that this industry is driven by automotive and offshore wind turbine OEMs, not by the defense sector, which is a tiny fraction of the demand. As you know, we always say, 2 weeks of our plant in Estonia, our separation facility in Estonia, are enough to supply the full defense needs of the United States. What do you do with the remaining 50 weeks? You can't have a business solely out of the defense sector. But actually, as of a couple days ago, I believe it was last Friday, there is a DoD decision that requires from 2025 onwards, and it's frankly a very bold decision that they made. By 2025, end-to-end rare earth magnet supply chains used for defense procurement that is outside of China and outside of Russia. This is a big deal. It's a small market, but clearly there is a mandated need from that as of last Friday in a DoD decision that came out. Now, as for the EU and my favorite jurisdiction that I've spent the last 2.5 years lobbying and explaining that rare earths are not used in the battery, but in the motor. The EU actually is a fascinating jurisdiction because, you know, its budget, unlike the US federal government, the EU's budget is like 1 to 16 versus the US budget. So it has a tiny budget. So it cannot use the financial incentives that the IRA, for example, can use. But what the EU has as the largest single market is the ability to raise standards, and for multinational companies that want to operate or sell, have commercial activities in the EU, if you want to access that market, you need to meet those high standards. And that is what Columbia Law School professor Anu Bradford would call the Brussels effect. It's the equivalent of the California and the Delaware effect for the regulatory geeks or nerds in the room. But the EU is, in lack of funding that it can offer, is using its regulatory superpowers. So as of the 15th or 16th of March, when it published the draft, the Commission, the EU Commission published the draft EU Critical Raw Materials Act, it's set by 2030 very bold and ambitious targets. For extraction, 10% of the EU's annual consumption happening domestically. There's currently no rare earth mining in the EU. For processing, 40%. For recycling, 15%. Like all magnets sold in the EU need to come from at least, or made in the EU need to have at least 15% from recycled feedstock. And no more than 65% of the European Union's annual consumption of any critical raw materials, including rare earths, can come from one single jurisdiction. There are also other regulatory superpowers that it will exercise or try to exercise. It has to go through the European Parliament and the EU Council. Welcome to Brussels. It will reduce or set time limits on permitting, whether it's mines or processing facilities. And it will require large companies such as renewable energy OEMs or drivetrain motor electric vehicle OEMs to actually disclose and do due diligence tests on human rights, on ESG, and on the percentage of sourcing from one jurisdiction, and even do company level stress tests and try to incentivize eventually. We'll have to see how the secondary legislation and the regulations will evolve over the coming years, how they will enforce maybe stockpiling for these OEMs. The problem with the EU, as great as its regulatory superpower is that it takes time to implement such policy. Time that OEMs don't have. And so I will leave you with a thought that it is very meaningful, both, I think, conversations like the one we're having at CIM, the partnerships that happen between jurisdictions, the Canada-EU Strategic Raw Material Partnership, the US-Canada Partnership, and so on and so forth. Because eventually these regulations, hyper-regulations or hyper-standards on one jurisdiction, and the high funding on another jurisdiction, and the commitment of Canada to act, frankly, faster than the US or the EU on individual projects that are strategic, so each jurisdiction has its own advantages and disadvantages, they eventually have to find an equilibrium, a steady state, to develop these supply chains outside of that one single jurisdiction. That was it from my end.